We're going to identify the solution to a system of equations by graphing. So we're going to look at three different types of solutions. So one solution is where if you have two graphs and they intersect at exactly one point, that one point would be the solution. And it's considered consistent and independent. Consistent means that your system has at least one solution, in this case exactly one. And independent, if you have a consistent system that has exactly one solution, is always called independent. So consistent and independent. Infinite solutions, so if you have two equations that you graph, and when they graph, they actually end up being the same line, one on top of the other. That means there's infinite solutions because they intersect at every single point. So it's called consistent and dependent. So consistent, at least one solution, in this case, infinite solutions. And so if your system has infinite number of solutions, it's called dependent, which means that they're an unlimited solution that satisfy both of the equations that have been graphed because they intersect at every single point. So no solution, when you graph your two lines, they will never intersect. That means no solution. The only way to have two lines that never intersect are if they are parallel. And these parallel lines are considered to be inconsistent because they will never have a solution. All right, so we're going to graph each system of equation and state its solution. So I need to first get these into a user-friendly form where I can graph them. So I like to put them in slope-intercept form, y equals mx plus b. That means I need to take my equation and solve for y. Then I can easily graph it. So my first one, I have negative 2x plus y equals 3. To get y by itself, I'm going to add 2x to both sides, and I get y equals 2x plus 3. Okay, so this one is in slope-intercept form. I can easily graph it. I know my slope is 2, my y-intercept is 3. So I'm going to start with the y-intercept. It goes through the y-axis at positive 3. The slope is positive 2. I'm going to make it into a fraction, so it's 2 over 1. So from my y-intercept, I'm going to rise 2, run 1. Then I'm just going to connect those. Make sure you get your line nice and straight. Let's see. So that we can identify where these two graphs actually intersect at. Okay, then my other one, here, I'm going to solve for my second equation over here. I have x minus y equals negative 2. Here I'm going to subtract x on both sides, and I get negative y equals negative x minus 2. But y can't be negative. So I'm going to divide everything on both sides by negative 1. Negative y divided by negative 1 is positive y. Negative x divided by negative 1 is positive x, or positive 1x. Negative 2 divided by negative 1 is positive 2. Okay, so now I know my y-intercept is 2, so it goes through my y-axis at 2. And my slope, it's actually 1x, so the slope is 1. But I want to make it into a fraction, so I always put a 1 below it. So I'm going to rise 1, run 1. Then I'm going to graph this. And I could continue with a few more points so I could really tell where the two lines intersected, but this one was pretty easy. They do intersect at this point. So there is one solution. The one solution is at negative 1, comma 1. And if there's one solution, it's called consistent and independent. So I'm going to write that down, and this is my answer. So I wrote the solution and that it's consistent and independent because there is exactly one solution. All right, so let's try another one. Okay, again, I need to solve for y. I have to get it into y equals mx plus b form. So I'm going to start with that top one. I have 8x plus 4y equals 12. I want y by itself, so I'm going to move my x term over. It's positive 8x, so subtract 8x on both sides. and we get 4y equals negative 8x plus 12. Y is being multiplied by 4, so I have to divide everything on both sides by 4. 4 divided by 4 is 1, so I'm left with y equals negative 8x divided by 4, negative 2x, plus 12 divided by 4 is 3. So that means my y-intercept is 3, slope is negative 2 over 1, so down 2 to the right 1. And I'm going to graph this, connect them. Whoops. Here's my line. And my second one. And solve down here, I have y plus 3 equals negative 2x. I just need to subtract 3 on both sides to get y by itself. So I have y equals negative 2x minus 3. So my y-intercept is negative 3. My slope is negative 2. I'm going to put it over 1. So down 2 to the right 1. And when I graph this, let's see, I can see that these two are parallel lines, which I could tell because if I look back after I solved, they both have a slope of negative 2. Anytime your slopes are the same, they're going to be parallel. Okay, so this one, okay, I'm going to write down the solution. So the solution is no solution because they are parallel. And when there's no solution, it's called inconsistent. All right, so I'm going to have you go ahead and try two very similar ones. And then when you're ready, I will go through the answers with you. All right, so that first problem, see, we have negative x plus y equals negative 2. Here we need to add x to both sides, and we get y equals x minus 2. So our y-intercept is negative 2. Slope, we have 1x here. I'm going to make it into a fraction. So we have our slope in rise over run form. So from my y-intercept, I rise 1, run 1. Then I graph it. All right, then the second one, we have 3x minus y equals 4. I'm going to subtract 3x on both sides. We get negative y equals negative 3x plus 4. Don't forget y is negative and it cannot be negative, so I'm going to divide everything on both sides by negative 1. Because y is being multiplied by a negative, opposite divide by negative. Negative y divided by negative 1 is positive y, equals negative 3x divided by negative 1 is positive 3x. Positive 4 divided by negative 1 is negative 4. So my y-intercept, negative 4, slope 3. So I'm going to rise 3, 1, 2, 3, run 1. And I can immediately see where they intersect. And so they do intersect in one point. So that solution, that point, is 1 comma negative 1. Remember, the x coordinate always comes first in your coordinate pair. And so whenever there's one solution, it's called consistent and independent. And all right, last one. Okay, so here, solve for y. We have 10x plus 5y equals 15. I'm going to subtract 10x on both sides, and I get 5y equals negative 10x plus 15. Divide everything on both sides by 5. 5 divided by 5 is 1. So we have y equals negative 10x divided by 5 is negative 2x, plus 15 divided by 5 is 3. So y-intercept is positive 3. Slope is negative 2 over 1, so down 2 to the right 1. Let me graph that. And then for my second one, we have x plus y equals negative 1. So I need to subtract x on both sides, and y equals negative x minus 1. So the y-intercept is negative 1. Slope is, well, negative x is the same thing as negative 1x. Make it into a fraction. So negative 1 over positive 1. Let's see. Here's my graph. And they do intersect down at the bottom here. So my point of intersection, x is 4. Y is negative 5. So there is one solution, and remember, one solution, consistent and independent. So in this one, we didn't have any that were infinite solutions, but remember, when you graph them, they just end up being the same exact line. And hopefully you were able to identify the solution of those systems of equations.